In this module, we will continue our look at the first of 4 stages of selecting a motor: requirements, infrastructure, standards, and environment, or RISE for short. Before we can determine the required motor power, we must find out the speed and the load torque characteristics of the application. An induction motor is normally a fixed single-speed machine. Its speed depends on the frequency of the electricity supply and the number of stator poles. Therefore, check the network supply frequency and match with a suitable motor speed. When the motor is running at full load, the speed is typically 3 to 4% lower. For motors driven by a variable speed drive, the maximum and minimum speeds must be taken into consideration, as it can affect, for instance, the cooling arrangement and bearing solution. Knowing the behavior of the load as a function of speed is extremely important, and we will look at 3 typical but different load torque characteristics. Applications that, after they start, accelerate and reach running speed and have a relatively fixed torque requirement are called constant torque. Typical constant torque applications would be elevators, hoists, conveyors, and positive displacement pumps. Sizing the motor for this type of application is simply calculating the power required as a function of speed and torque using this formula, and then selecting a motor with a suitable output rating. The next 2 examples cover applications where the load torque varies as a function of speed. For these applications, you normally size the motor for the highest continuous load, which is usually at the highest speed. Rolling and processing of paper, textiles, and rubber tiles, as well as extruders, are examples of applications where the load torque increases in proportion to speed. Our last example is for applications where the load torque increases with the square of the speed. This usually happens where there is gas or liquid friction, as found in many of the most common motor applications, such as blowers and fans, centrifugal pumps, propellers, and most mixers. In applications with this relationship between power and speed, it is possible to make huge energy savings by adjusting the speed of the motor with a variable speed drive, instead of controlling the amount of gas or liquid with a slide valve or throttle valve. It is very important to check the duty cycle. Will the motor run continuously or in an intermittent duty cycle? In the IEC 600-34-1 standard, there are 10 duty types defined from S1 to S10. The calculation to determine the required power based on the duty cycle is not easy. Therefore, manufacturers of premium motors offer computer programs for quick and reliable calculations. Now that we have determined the required motor power, we should also check the mechanical load forces. Axial and radial forces have an impact on the bearing lifetime, and in case of very high radial forces, also on the shaft dimensioning. Speed, load torque, and duty type form the basic information needed to determine the correct motor power for our application. But as we will see in the next module, often network restrictions on starting current will influence the choice of motor.